Okay, so I'm going to I'll go over the questions on the trig test, and then you can skip through the video wherever you miss questions and figure out how to answer them. And then if you'll figure out your mistake, because that's a part of the learning process, and you can do corrections, get half credit back, just like we always do. So, okay, so here's the answers for these, and I've kind of color-coded them. So we're just finding Pythagorean theorem. So for the first one, it would be x squared plus 6 squared equals 17 squared. So I'm going to get x squared plus 36 equals 289. If I subtract the 36 over, I get 253. And then if I square root both sides, that's how I get 15.9. So for number 2, I'm going to set it up like 9 squared plus 15 squared equals x squared. So when I add these together, I get 306 equals x squared. And then when I take the square root of both sides, that's how I get 17.5. Alright, so for number 3, I'm going to set it up as x squared plus 8.5 squared equals 11.2 squared. I'm going to get everything, all the numbers to one side, so I get x squared equals 53.19. And then when I take the square root of both sides, I get 7.3. For number 4, I'm going to set it up as x squared plus 12 squared equals 24 squared. Alright. Okay. And oh, the reason I got 24, sorry, I just confused myself, is that it says it's an equilateral triangle, so half of 24 is 12. So that's how I got that other side was 12, in case you're wondering. So I get x squared plus 144 equals 576. I'm going to subtract 144 over, so I get x squared equals 432. And then when I take the square root of both sides, I get that x is 20.8. Okay, so for B and E, I'm going to draw a picture. Okay, so for B, I would set that up as 13 squared plus 7 squared equals x squared. When I add all the numbers together, I get 218 equals x squared. I take the square root of both sides, and that's how I get the 14.8. For part E, I would set this one up as x squared plus 19 squared equals 28 squared. X squared plus 361 equals 784. I subtract 361 to the other side, so x squared equals 423. And then when I take the square root of both sides, that's how I get 20.6. So if you missed any of those, hopefully you know how to do them now. If not, you can always ask me for extra help. Okay, so for number 2, fairly easy. This was using special right triangles, but you could have also used trig. Hint, hint, hint. So, this is what it says. So these two are, oh, sorry, my elbow hit it. These two are equal, so x would be 13. And then if we're looking at those, like the special right triangle properties, I guess I would say, it's whatever the side times the square root of 2. So that's why this one is 13 times the square root of 2. If that doesn't make sense, go back and watch that video because we talked about it there. Alright, so here's my 30, 60, 90 triangle. So if the shortest side is 4, the hypotenuse is 2 times that, and 2 times 4 is 8. So that's how I got that. Alright, so for number 4, we're doing a 30, 60, 90 again. I'm finding y, and so this is 30 degrees. Y is my shorter side. So remember, if this is s, then this is s times the square root of 3. So I know something times the square root of 3 gave me 21. If I divide by the square root of 3, I get x equals 21 divided by the square root of 3. Can't have a radical in the denominator, so I'll multiply the top and bottom by the square root of 3. So the top actually becomes 21 square root of 3. The bottom is 3. And then I can reduce this. 21 divided by 3 is 7. So 7 square root of 3. That's how you get D. This one, once again, using those special right triangles, but you could also use trig if you just hate using that. So, let's see. I'm trying to figure out which one's easier to start with. Alright, let's do this. So, if this is my hypotenuse, then I know my shorter side is half that much, so it's 12. And then I know my longer side, z over here, is 12 times the square root of 3, because it's always the shorter side times the square root of 3. Okay, if I look at the 45, 45, 90 triangle, I know these two are equal, so that's why y has to be 12. And then the hypotenuse on those is always the longer side times the square root of 3, so that's how I get 12 square roots of 3. So I kind of color-coded that wrong in the picture. Sorry about that. But that's how you get those. Alright, so this one's pretty easy. All you have to do is find... oh, did I really spell it like that? Oh, the tangent. Alright. Okay. So I just wanted you to find the ratios. So the first thing you need to do is use Pythagorean theorem to figure out this side over here. So you could set that up 16 squared plus x squared equals 20 squared. So you get 256 plus x squared equals 400. I'm going to subtract 256 over. I get 144. I get the x is 12. So now I know that this side over here is 12. Okay, so when I want to find the sine of A, it's right here. Remember, sine is opposite over hypotenuse. That's how I got 12 over 20, which reduces to 3 over 5. Okay. If I wanted to do, let's see, the cosine of A, cosine is adjacent divided by hypotenuse, 16 over 20, which reduces to 4 over 5. That's how I got that one. And then if I want to do the tangent of A, remember that's my opposite over my adjacent, so 12 over 16, which reduces to 3 over 4. Okay. Alright, so for this one we were actually solving. So we were trying to find the missing side links in 1, 2, 3, and 4, and then we were trying to find the missing angles in 5 and 6. Alright, so part A I would have to set up as cosine 42 equals x over 15. When I multiply both sides by 15, I get x is 11.1. Alright, for number 2, I would set that one up as the sine of 31 equals 11 over x. Multiply both sides by x, then divide by sine 31. I get x is equal to 21.4. For the third one, I would set it up cosine 18 equals 29 over x. Multiply both sides by x, then divide by cosine 18. I get 30.5. For number 4, I would have to use the tangent of 70 equals x over 6. Multiply both sides by 6. I get x is 16.5. For number 5, I'm going to have to use inverted sine because I'm looking for an angle. 17 over 9, and when I put that in my calculator, I get 63.5 degrees because we're talking about an angle. And then for E, I would have to use invert cosine 21 over 25, and when I put that in, I get 32.9. So if you set these all up and you're like, I did it right, make sure that your mode was in degree mode or you would have gotten all the wrong answers. Alright, and then we did our application problem. So I've went ahead and I've drawn the picture for you. So then you would use tangent. Tangent of 39 equals x over 778. Multiply by 778 and you get x is 630. For number 10, there's your picture. You have to use the tangent function. Tangent of x equals 199 over 132. Because you're finding a missing angle, you're going to use inverse tan. And when you put that in your calculator, you get 56.4, and that's degrees. Number 11, remember that these are alternate interior. That's why you can do that. And then I would have to use tangent again. Tangent of 63 equals 18 over x. Multiply both sides by x. Divide by tan 63. You're going to get 9.2. And number 12, I think, is the hardest. Just drawing the picture. You're going to use tan again. So tan 77 equals 3,440 over x. Multiply both sides by x. Divide by tan 77. X is equal to 794.2. If you need further explanation, let me know. Do your test corrections. Tell me why you missed the problem. I know you know how to do them because I just went over them, and I know you know the answer because it tells you the answer, but I want you to figure out what mistake did you make, and then hopefully you don't make it again. So let me know if I can help you, and turn in those test corrections.